Here's a typical example of a radical question that you'll come across in an algebra class. Oftentimes, instead of just a basic square root of something, they'll give you another root, in this case a cube root, or you could see a fourth root or a fifth root, or basically any power. And they're all treated the same way. And in fact, you know how to do these. You know how to do square roots. You know how to reduce square roots with powers of variables and with numbers, fractions. You know how to do all of this if it was a square root. When they throw the cube root at you, you start to panic because you've gotten so good at square roots that you just kind of do it on autopilot and you forget what it is that you're actually doing to reduce a square root. You know, the reason why the square root of 9 equals 3 is because really you're doing the square root of 3 squared, which is really 3 squared to the 1/2 power, because that's what a root is. It's a 1 over power, right? So a square root is a 1 over 2 or a 1/2 power. And you know that the rule is that when you have something raised to a power again, you multiply powers. And that's 3 to the 2 times 1/2, which ends up being 3 to the 1, which is just 3. Right? So dealing with roots really just comes down to the rule of if you have x to the a raised to the b, it ends up being x to the ab, right? You multiply powers. So something that's raised to a power again, you multiply powers. And so now in order to do a cube root, all you have to do is think about changing everything to a 1/3 power, right? And then simplify things. And then of course you have to deal with numbers because, you know, what's the third, 1/3 power or cube root of 64? Well, the other skill you have to remind yourself is coming up with prime factorization. So you want to factor numbers out into their full list of prime numbers. So just start with the first prime number that you see that divides into it, or really honestly, just start dividing it out and just make sure you get all the numbers. So let's say you look at this and you go, well, I know it's divisible by 2. And that's 32. And then you look at this, you go, hey, that's 8 times 4. Okay, well then keep going, right? This is 2 and 2. This is 2 and 4. And then 2 and 2. And once you're finally done, at the end of all your branches is your prime factorization. So 64 ends up being how many 2's? 1, 2, 3, 4, 5, 6, 6 of them. 2 to the 6th. And then we can do the same thing with 125. Well, 125 is obviously divisible by 5. And then you do the math and you go, oh, that's 25. And then that's, of course, 5 times 5. So 125 is 5 cubed. Okay, so now we can rewrite this original thing as 2 to the 6th, x to the 8th, y to the 9th, over 5 cubed, z to the 4th, and this whole thing, because it's a cube root, right, is raised to the 1/3 power. And now, using this simple rule, and we know that if we had x, let's say to the a times y to the b, and the whole thing was raised to the c, we know the rule is it's x to the ac, y to the bc, right? As long as everything is multiplication and division, powers just distribute. It's when things are separated by pluses and minuses that it gets tricky. So if it was, x to the a plus y to the b or minus y to the b, then it would be completely different. We would have to use foiling and those types of techniques. But for this one, because it's all just simple multiplication, everything's just multiplied together, and then the whole thing is one big fraction, which is just division, we can just distribute this power, right? We can just put it onto everything. So it's going to be 2 to the 6th to the 1/3. So 6 times a third, right, is just going to be 2, right? So it's going to be 2 squared. X, well, this is just to the 8/3, right? It's not a whole number. We're going to have to deal with that in a second. All right, to the 9th times 1/3, so 9 divided by 3 is 3. 5 to the 3 to the 1/3, so that's just going to be 5. And then, of course, z to the 4/3. Okay, well, anything that still has a fraction is still being rooted, if you want to think of it, right? It's still stuck in the root. But everything else is out. It's all popped out of the root, right? So this no longer has a third on it, so it comes out of the radical. And we just have 4. And this comes out as well, right? We've got y cubed. And on the bottom, of course, we have 5. But what do we do with this? Well, 8/3, and this looks horrible, but this is a 4/3, right? That's a 4. That looks even worse. Let me fix that, sorry. There we go. 8/3, well, what is that as a mixed number, right? How many times? Actually do the division. Do 8 divided by 3, and you go, okay, well, that goes in 2 times, which gives us 6, right? And then it's left over. So it's 2 2/3, right? That's what 8/3 is. So that means the 2, the whole number, that's what's on the outside, x squared. And then the 2/3, that's what's still stuck inside the cube root. And the cube root, remember, is the 3 on the bottom, right? That's the 1/3. So this 2/3 really is the same thing as 2 times 1/3. So this takes care of the 1/3, and what's left on the inside is x squared from this 2. And then the same thing happens on the bottom. All right, we still have a cube root down here of some of these z's. So we do 4/3, and of course when we do the whole division thing, that brings one of them out, right? And one of them is left, right? Because 4/3, you do the division, goes in there once, and there's one left over, so it's 1 1/3. So here's my 1, and here's my 1/3. We just don't write them in. And then, of course, we would clean this up. We wouldn't have these two radicals. We would just write it as 4x squared y cubed 5z, and then we would have the cube root of x squared over z. And that has now been completely reduced. And you can use this technique for, anything. It doesn't matter how ugly or confusing it gets. The idea is you're just applying a power, right? Radicals are just exponents in disguise. So instead of a cube root, it's a 1/3 power. And then you just have to realize that when you have a number that doesn't divide evenly by whatever your root is, right? So if it doesn't divide evenly by 3, then the whole number is what goes out, and the remainder is what's still trapped underneath the radical. Because basically, when you have x to the 8 power right up here, right? That's 8 x's, right? 3 of them clump together, get cube rooted, and become 1 on the outside, and then another 3 get clumped together and get cube rooted and become the second one on the outside. That's why there's 2 of them. And then you have 2 left over, and these are the 2 that are left over on the inside. So however you want to think about it, that's what's going on, and this is an easy way to tackle radicals.